Beneath the surface of our planet, immense forces are constantly at work, shaping the landscape in ways that defy imagination. These forces have created some of the widest and most dramatic cracks in the Earth's crust, vast rifts that stretch for thousands of kilometers. What lies within these colossal fissures? From hidden volcanic activity to the birth of new oceans, these rifts hold mysteries that challenge our understanding of the world. Let's take a closer look at these 10 awe-inspiring cracks that reveal just how dynamic and powerful our planet truly is. The East African Rift is a major geological feature that stretches over 3,000 kilometers from the Afar Triple Junction in the northeast of Africa down to Mozambique in the southeast. This rift is a tectonic boundary where the African plate is splitting into two smaller plates, the Nubian plate to the west and the Somali plate to the east. This process, known as rifting, is slowly pulling the continent apart, eventually forming a new ocean basin. The East African Rift is characterized by a series of deep valleys, towering volcanic mountains like Mount Kilimanjaro and Mount Kenya, and numerous active volcanoes. The rift is also associated with significant seismic activity due to the tectonic movements. Lakes such as Lake Tanganyika and Lake Malawi have formed in the rift's depressions, creating some of the deepest freshwater lakes in the world. The region is not only geologically significant, but also rich in biodiversity and human history, being home to some of the earliest hominid fossils. The East African Rift plays a crucial role in understanding continental drift and the dynamic processes shaping Earth's surface. The Baikal Rift Zone is a significant continental rift located in Siberia, Russia. It is centered around Lake Baikal, the world's deepest and oldest freshwater lake, with a depth of over 1,600 meters and an age of about 25 million years. The rift extends for approximately 2,000 kilometers from the Mongolian border in the south to the Yenisei River in the north. The Baikal Rift Zone is unique because it represents an active rift within a stable continental region, unlike most rifts that are found at divergent tectonic plate boundaries. The rift is caused by the stretching and thinning of the Earth's crust, which is leading to the gradual widening of the rift and deepening of Lake Baikal. This tectonic activity is also responsible for frequent earthquakes in the region, making it one of the most seismically active areas in Russia. The rift zone is geologically complex, with a series of fault lines, volcanic activity, and geothermal features. The Baikal Rift Zone plays a critical role in understanding the processes of continental rifting, intraplate earthquakes, and the formation of deep lakes, making it a key area of study in geology and geophysics. The Rio Grande Rift is a major geological rift in North America, stretching from central Colorado through New Mexico into northern Mexico. It extends for about 1,000 kilometers and is one of the few active continental rift zones in the world. The rift is responsible for the formation of the Rio Grande River Valley, which has shaped the landscape of the southwestern United States. The Rio Grande Rift is a result of tectonic forces that have been pulling the Earth's crust apart for the past 30 million years. This extension of the crust has created a series of basins and ranges, with alternating valleys and mountain ranges, including the Sangre de Cristo and Sandia Mountains. The rift is also associated with significant volcanic activity, particularly in the northern and central parts, where lava flows, cinder cones, and volcanic fields are common. Seismic activity along the rift is relatively low compared to other rift zones, but the region remains geologically active. The Rio Grande Rift is an important area for studying the processes of continental rifting, as it provides insights into how continents break apart and the formation of new ocean basins. Additionally, the rift influences groundwater flow, making it vital for the water resources in the arid southwest. The Great Rift Valley is a massive geological and geographical feature that stretches over 6,000 kilometers from Lebanon in the Middle East to Mozambique in southeastern Africa. It is part of an extensive rift system that marks the divergent boundary between the African plate and the Arabian, Nubian, and Somali plates. The Great Rift Valley is one of the most significant rifts on Earth, both in terms of its size and its impact on the landscape, biodiversity, and human history. The valley is characterized by a series of steep escarpments, deep valleys, and large lakes, such as Lake Victoria, Lake Tanganyika, and Lake Malawi, some of the world's largest and deepest freshwater lakes. Volcanic activity is prominent along the rift, with active volcanoes like Mount Kilimanjaro and Mount Kenya located nearby. The rift is also prone to earthquakes due to the ongoing tectonic movements. Ecologically, the Great Rift Valley is home to diverse ecosystems, ranging from savannas to forests, supporting a rich array of wildlife, including many endemic species. It is also a region of great anthropological significance, as it is considered the cradle of humanity, where some of the earliest human fossils have been discovered, offering crucial insights into human evolution. The Great Rift Valley remains a vital area of study for understanding the dynamic processes shaping the Earth's surface and its impact on life. The West Antarctic Rift System is a vast geological rift located beneath the ice sheet of West Antarctica. This rift system is one of the least understood yet most significant rift zones on Earth, stretching over 3,000 kilometers from the Ross Sea to the Weddell Sea. The rift separates the West Antarctic ice sheet from the more stable East Antarctic ice sheet and is responsible for the thinning and movement of the ice in this region. The West Antarctic Rift System is characterized by a series of deep basins and elevated mountain ranges hidden beneath the ice. These geological features have been revealed through radar and seismic studies, which show that the rift is slowly pulling the continent apart. The tectonic activity associated with the rift contributes to the geothermal heating beneath the ice, which may influence the flow of ice streams and glaciers, making the region more vulnerable to climate change. Volcanic activity is also present along the rift, with several subglacial volcanoes identified, though most are dormant or inactive. The rift's role in ice dynamics and its potential impact on global sea levels make it a critical area of study in understanding both geological processes and the future stability of the Antarctic ice sheet. The West Antarctic Rift System continues to be a focus of scientific research due to its implications for climate change and rising sea levels. The Red Sea Rift is a tectonic rift located between the African and Arabian plates, running along the axis of the Red Sea. It is a classic example of a divergent boundary where two tectonic plates are moving apart, leading to the formation of a new ocean basin. The rift extends approximately 2,000 kilometers from the Gulf of Aqaba in the north to the Bab el-Mandeb Strait in the south. The Red Sea Rift is an active spreading center where the Earth's crust is being pulled apart, creating a series of mid-ocean ridges and deep troughs. This process is gradually widening the Red Sea, and over millions of years, it is expected to evolve into a full-fledged ocean. The rift is associated with significant volcanic and seismic activity, particularly in the southern part, where volcanic islands such as the Zubair Group have formed. The geological activity of the Red Sea Rift has a profound impact on the surrounding region. It influences the hydrothermal systems in the area, leading to the formation of mineral-rich brine pools on the seafloor. Additionally, the rift plays a crucial role in the geological evolution of the Arabian Peninsula and the Horn of Africa, contributing to the unique landscape and tectonic setting of the region. The Red Sea Rift is a key area of study for understanding the processes of continental breakup and ocean basin formation. The Basin and Range Province is a vast geological region in the western United States and northwestern Mexico, characterized by a series of parallel mountain ranges and valleys, or basins, that extend over 800,000 square kilometers. This region is the result of extensive tectonic stretching and thinning of the Earth's crust, which began around 17 million years ago and continues today. The Basin and Range Province stretches from eastern California and western Utah down to Mexico, encompassing parts of Nevada, Arizona, and New Mexico. The formation of the Basin and Range Province is primarily driven by the extensional forces related to the movement of the Pacific and North American plates. As the crust is pulled apart, It fractures and forms fault lines, creating the alternating pattern of mountains and basins. This process also gives rise to significant seismic activity in the region. Volcanism is a notable feature of the basin and range, with numerous volcanic fields and calderas scattered throughout the area. The province's geology is also marked by extensive mineral deposits, including gold, silver, and copper, which have been historically important for mining. The region's unique topography significantly impacts the climate, ecosystems, and hydrology. The basins often contain endorheic lakes, such as the Great Salt Lake, and arid deserts, while the mountain ranges can support forests and more diverse wildlife. The Basin and Range Province is a crucial area for studying the dynamics of continental extension and the interplay between tectonic, volcanic, and erosional processes. The Mid-Atlantic Ridge is one of the most prominent and longest mountain ranges on Earth, stretching approximately 16,000 kilometers from the Arctic Ocean to the Southern Ocean. This underwater ridge is a divergent boundary between the Eurasian and North American plates in the Northern Hemisphere and the African and South American plates in the Southern Hemisphere. The Mid-Atlantic Ridge is a key feature of the global mid-ocean ridge system, where tectonic plates are slowly moving apart, creating new oceanic crust. The process of seafloor spreading at the Mid-Atlantic Ridge is driven by upwelling magma from the Earth's mantle. As the plates pull apart, magma rises to fill the gap, solidifying to form new oceanic crust. This continuous process has resulted in the formation of a central rift valley along the ridge, which is flanked by towering underwater mountains. The Mid-Atlantic Ridge is also associated with significant volcanic activity, including the formation of volcanic islands such as Iceland and the Azores. These islands are the above-water expressions of the ridge, providing a unique glimpse into the geological processes occurring beneath the ocean. The ridge is a site of frequent seismic activity, including earthquakes and volcanic eruptions, due to the constant movement of the tectonic plates. Additionally, hydrothermal vents along the ridge support unique ecosystems, with communities of organisms that thrive in the extreme conditions created by the venting of hot, mineral-rich water. The Mid-Atlantic Ridge plays a crucial role in understanding plate tectonics, seafloor spreading, and the dynamic nature of Earth's crust. The Gakkel Ridge is a mid-ocean ridge located beneath the Arctic Ocean, extending for about 1,800 kilometers between Greenland and Siberia. It is the slowest spreading and deepest mid-ocean ridge on Earth, with a spreading rate of only about 1 centimeter per year. Despite its remote and inhospitable location, the Gakkel Ridge is a critical area for understanding the processes of seafloor spreading and tectonic activity in the polar regions. The Gakkel Ridge is unique due to its extremely slow spreading rate, which results in a narrow and deep rift valley. The ridge is also characterized by significant volcanic and hydrothermal activity. In 1999, scientists discovered large volcanic eruptions along the ridge, despite the expectation that such a slow-spreading ridge would be relatively inactive. The volcanic activity is accompanied by hydrothermal vents, which support diverse and unique ecosystems, even in the extreme conditions of the Arctic deep sea. The Gakkel Ridge's slow spreading rate and harsh environment have made it challenging to study, but recent expeditions using icebreakers and remotely operated vehicles have provided valuable insights. The study of the Gakkel Ridge contributes to our understanding of mid-ocean ridges, deep-sea ecosystems, and the geological history of the Arctic Ocean. Its exploration has implications for understanding global tectonic processes and the potential for life in extreme environments. The Afar Triangle Rift, also known as the Afar Depression, is a geological wonder located in the Horn of Africa, where three tectonic plates, the African, Arabian, and Somali plates, are slowly pulling away from each other. This rift is part of the larger East African rift system and is one of the few places on Earth where an oceanic rift is visible above sea level. The Afar Triangle is characterized by its unique geological features, including active volcanoes, deep rift valleys, and the Danakil Depression, one of the hottest and lowest places on Earth. The region is marked by significant tectonic activity, including frequent earthquakes and volcanic eruptions. The Erta Ale volcano, known for its persistent lava lake, is one of the most active and iconic features of the Afar Triangle. The rifting process in the Afar Triangle is gradually leading to the formation of a new ocean basin, as the land continues to stretch and thin. The Afar Triangle's harsh environment, with extreme heat and high salinity, has also led to the formation of unique ecosystems, including hypersaline lakes like Lake Assal and the alien-like landscapes of the Dalol hydrothermal fields. The area is of great interest to scientists studying tectonics, volcanism, and extremophiles, organisms that thrive in extreme conditions. The Afar Triangle is a crucial site for understanding the processes of continental breakup and the birth of new oceanic crust.